So, we are looking at one more question, and the question says that the main peaks in the mass spectrum of an alkene, a ketone, and a carboxylic acid are listed below, but it is not known which is which. Now, the task at hand, we are required to assign each molecule with the right mass spectrum and write a structural formula in each case. Now, we have mass spectrums A, B, C that have charge to mass ratios of 60. Now, when you talk of charge to mass ratios, this is the same as the molecular mass. This we can call it the relative molecular mass, that we can abbreviate as RAM. So now we need to find out which spectrum is for an alkene, which spectrum is for a ketone, which spectrum is for a carboxylic acid. But they say with reasoning. The question was, assign each molecule with the right mass spectrum and write the structure formula in each case and give a reason. Now, we begin maybe with analyzing the mass spectrum A, and we see where does it lie. Now, if we can list the compounds which we have. One, we have an alkane. An alkene, let's say for the alkane, alkenes conform to general formula CN, H2N plus 2. This is the general formula. Now, the biggest value here, we take it to be the mass of the molecular ion, before it is fragmented. These other masses that we are seeing are the masses of the fragments. Now, if I realize that this is the general formula for an alkene, let me try out equating it to one of these ones. Which one gives me N as a whole number? Here, let's try with maybe 58. So assuming this is equal to 58, then carbon is 12. This is 12N plus 2N plus 2, which is equal to 58. So 12 plus 2, this gives me 14N plus 2, which is equal to 58. Now, these two crosses equal signs, and then we are left with 14N is equal to 56. Now, we divide through by 14 to get the value of N, and we realize that N is 4. Now, if N is 4, let's try putting it here, and we see the type of alkene that will come out, and see if it corresponds to any of those. So this means this is CH4, H, this is 2 times 4, 8 plus this, that is 10, and the structure of this molecule should be CH3, CH2, CH2, CH3. So let us see if this is our molecular ion. When we fragment it, when we get fragments, when I say we are getting fragments, it means we are losing small parts with time. Now, let us see. If we lose, okay, the whole of this, when we add it up, we realize that it corresponds to 58. But we have two 58s, so we can't say that the alkene is B or C. We have to proceed and see. Now, let us fragment it and come up with CH2, CH3, CH2, CH2. We have lost a methyl group. So when we lose a methyl group totals to 15. This is 12 plus 3, that is 15. So 48 minus 15, we get 43. So 43 corresponds to this molecular ion. Now let's proceed. When we proceed, we are now having this molecular ion. Let us fragment it further. If we remove this CH2, we are going to come up with CH3, CH2. This is another molecular ion. Now, this has been reduced by, this is 12 plus 14. It has been reduced by 14. Therefore, 43 minus 14, we get 29. Therefore, 29 corresponds to this molecular ion. Now let's lose also this other molecule, and we remain with CH3 as a molecular ion. This is 24 minus 14, we get 15. That corresponds to this molecular ion. And now, looking at this from this analysis, we can now conclude and say that the molecule that has fallen in this train, that has 58, 43, 29, 15, that this is the alkane. The alkane. And what is the structure? This is CH3, CH2, CH2, CH3. Okay? So they say we should give a reason for that. So the reasons we have given is that the charge mass ratios correspond to these molecular ions. So you can say that more precisely, this we can say has been rough work. We shall say that the mass spectrum C is for the alkene. And we say that the mass ratio 58 corresponds to molecular ion CH3, CH2, CH2, CH3. When we say molecular ion, and we said all these ions produce the mass spectrometer, are positive, then 43 for CH3, CH2, CH2, with a plus, then 29 for CH3 CH2 plus, and 15 for 15 is for CH3. So we have given reason, we have known the type of molecule, and we are in position to deduce the structure of that molecule. So that's how we could answer such a question. If we are faced with such a scenario, this is the way to go about that scenario. Now, we are still proceeding with identifying the other mass spectrum. Now, let us look at another scenario, because we need to fill our table at the end of the day with the substantial reasons. Now, they said that one of the mass spectrum is for a carboxylic acid. So let us look at the carboxylic acid. The general formula for a carboxylic acid is RCOOH, where this is called the carboxyl group, and R stands for an alkyl group. Now, let us find out if which carboxylic acid adds up to 60. For a carboxylic acid, this would be R equaling to 12 plus 32 plus 1 equaling to 60. So what is the nature of R? This plus this is 30, this is 30, what does it give? This is 44, then 45, therefore R plus 45 gives us 60, meaning the R is 15, and we said R is an alkyl group. So if R is an alkyl group, this means that our carboxylic acid is of this nature. So if our carboxylic group is of that nature, then we should find out where do these fragments correspond. Now we have known that the mass ratio at 60 is now the mass ratio for 60 is for the molecular ion, which is the carboxylic acid. Then let us try to make fragments out of the carboxylic acid. Now, if we make fragments out of the carboxylic acid, for example, if we lose a methyl group, if we lose this methyl group and we remain with the carboxyl group, when we look at this, you realize that it corresponds to 45. So this corresponds to EM 45, and then 15 is for the molecular ion, CH3. So here we are good to go that this is the carboxylic acid, that is the carboxylic acid. Then its structure, we found out that is CH3COO. Now, definitely we had 3 mass spectrums, the 2 have been taken up. It shows that this one is for the ketone. But what is the general formula for a ketone? For carbonyl compounds, the general formula for carbonyl compound is CH2N minus 1 and then with an oxygen. Now if we analyze this, this should be equal to 58. So this is 12N plus 2N minus 1 plus 16 is equal to 58. So this plus this is 14. That plus that, this is 14N, this is 15, which is equal to 48. 14N is equal to 48 minus 15. Is it 15? Yes. Minus 15. So if this is 15, 58 minus 15, it gives me 30. What is 58 minus 15? This one. Okay. Sorry. More clearly, let's look at a ketone. A ketone. Now, when we recall, you realize that this and this almost